Hello everyone. Today is day 20 of us solving 30 problems in 30 days, 30 machine learning problems in 30 days. So, the problem is about to create a topic model using latent uh, Dirichlet allocation. So, I don't know what is latent Dirichlet allocation, and so let's start it. Uh, So I'm going to do what I'm going to. I have already asked so about this, and I've always I was recording it already, but I was facing some issues with ChatGPT. So the code is already being prepared. I mean, being provided by ChatGPT. Also, the data set that I'm going to use for this is going to be from this problem from Kaggle, which is New York Times Comments, and I'll be using this April's articles April 2017.csv. I have downloaded it and then moved it to my dataset folder of this 30 days machine learning challenge repository, and this is what you can see. I've also created a file called day underscore 20.py where I have imported pandas as a PD, loaded this CSV file, and this is how this data is looking. It has 16 columns, and this is how it is looking. Okay, now let me go and see what chat gpt has helped me with. So it says that the LDA topic modeling project from New York dataset includes steps like data resource pre-processing, LDA model building, and visualization. I'm saying here it provides me the steps, but let me say, can you provide detailed dis can you please explain each step in detail? Okay. It says we have to use NLTK. NLTK helps us in pre-processing with the with doing tokenization, stop words, and lemmatization. Hmm. Sorry, someone was at the door, so I had to open it. Hmm. So I have to import the libraries. Dataset, pre-processing setup that I have to do what I have to import this natural language toolkit, which is going to help me pre-process the tokenization, stop words, and lemmatization. Mm, okay. I have used the regular expression library in Python, which we use to remove unwanted characters, punctuation. Gensim, a library for topic modeling that implements LDA, as well as word embedding, text similarity, and more. PYLDA is a visualization tool specific for LDA topic models, which provides an interactive display for topic. Okay, I understood this, but what is LDA? Can you please is LDA? Okay, so I'm going to use now Claude. So it has stopped working. I'll go and use. I will be using my personal email for using Claude. The statistical model we use machine learning language. It's primarily used for topic modeling and text analysis. LDA helps discover abstract topic in a collection. Okay, so LDA helps in discovering the abstract topics in a collection of documents. It assumes that each document is a mixture of various topics, and each topic is a distribution of words. Okay, it analyzes the word patterns in a set of documents. It refers the topic that might have generated those patterns, and it assigns those the topic probabilities to each document. So what it does, it identifies patterns from the collection of documents. Application: text classification, document clustering, content recommendation. Okay, yes. Trend analysis. Can you help me with uh, the code code for solving this? Please explain each step and be as basic as possible. I guess this, for now we can go ahead with this problem because this seems more fun to solve, because this is the first problem on NLTK, natural language. This is a full form of NLTK, natural language toolkit, and I don't want to start with something complex, so I think we should go ahead with what Claude is saying. And let's, yes, so first we are going to import the libraries. We import Gensim for LDA modeling, NLTK for text processing, and other necessary modules. That's the same thing that ChatGPT provided. Prepare the data. We define a small data set of documents. In real scenarios, you load your document from files or database. Define the text preprocessing function. Okay. Preprocess all documents. Okay. Corpus बनानी है. Then we have created a corpus, and then we are going to create a LDA model using the corpus dictionary and specified number of topics. Print the topics. The discovered topics from each distribution and infer topics for a new diff document. We now show how to use the train model to infer topics for a new unseen document. So the new document, the cat is playing with a toy. And what we are doing a dictionary, creating a dictionary. What we are converting to it to vector representation for each index and score in the LDA model, and specify this go vector using the lambda function. We are printing the score. And let me see what ChatGPT has to say here. Okay, okay, we can maybe go with this also. So let's import the library as it says. Import regular expression, import NLTK. I don't have an NLTK installed, so I'll have to do that. Install NLTK. NLTK. From NLTK corpus, import stop words from NLTK tokenize, import word, tokenize from NLTK stem, import word net lematizer from Genesis. I will have to install this Genesis also. And why are we using it? We are using it this library for topic modeling that implements LDA as well as word embedding text. So we'll be doing creating, I guess, the LDA model using this library only. Yes, correct. See, that's what we are doing here. Let me go back and install this first. Pip install gen sim, and then I'm doing gen. Just give me a second. Huh? Yes, mummy, my mother was calling actually. So I have installed it. I'm going to import it from Jensen. Import Corpora. Import Jensen, and then import pval LDA. So I don't have this installed, right? So I'll have to install it. Pip install. So let me import it. Jensen. Yes, sorted. Now let's go back. We have the data. Select the snippet column. We have to select the snippet column, and how the snippet column is looking. Let's go back to our data. Mhm. This column, right? So I'm going to do what? Select the snippet column, copy it, paste it. I'm doing what? Text data. Data snippet, drop the missing values, and return after dropping the missing values, return in the list format. Return this test data, print this test data, comment this, and now run this file to see what is in the sorry what is in this. Yes, so this is our list. We see the corpus of data. We can go back here, and if we see the snippet, here I can see maybe. So it does not show the snippet column, but yeah, we can see the snippet column contains the snippet of the connects, as in comments. So I'm curious to see what is in the data. Row column 1. I'll comment, sorry, I'll comment this and try to print it. And get 0. If I do, if I do, yes, let's see if this is having the data. We saw how it is looks. It looks below the New York Times Comments Dataset into a panda document. This dataset has a multiple columns, but we are interested in text-related columns. We use the snippet column, which contains a short text snippet of the article. This will be our source of text for the topic modeling. So what we are doing? Okay. Okay. So we have got the data. Now we are going to do pre-processing setup. So I will minimize it a little, and this is going to be step 2, pre-processing setup. Here what we want to do, here we want to download the we download the NLTK stop words tokenization and lemmatization sources so that we can process the data. So stop words are the words, um, mm, so words are like words is, in, etc., which do not contribute much to the meaning of the text. So we do need to remove those words. So we are removing those words to improve the quality of the topic modeling. Lemmatization. This reduces words to their base form. For example, running becomes run. Running becomes run. This is lemmatization. Uh, so let's do that. NLTK download stop words. Going to copy it. NLTK download PUMKTK. This is where it stores the libraries. Then download WordNet, and then we are going to create this stop words are going to be set stop words dot words English. The stop words will be of English language. Lemmatizer. Let's initialize the lemmatizer. Lemmatizer. It is going to be word lemmatizer. Word lemmatizer. Then we will go text preprocessing. Step number 3 is text preprocessing. Here we are going to create a function which is to first we will convert to lowercase so that all function will be having the same base. Then we are going to remove the punctuations using the regular expression. These are the unwanted punctuations which do not contribute anything to the quality of the sentence. So quality of the data. So we are going to remove that, like dot, comma, exclamation mark. Then we are going to split it into uh, tokens, small tokens, or that is individual words, that is tokenization. And then we will apply stop, we will remove the stop words and do the lemmatization. Lemmatization again going to be from running to run, convert into base form. So let's do all of that. Create a function def preprocess text, and here we are going to do what? Convert to lowercase, convert to lowercase, and here text will become text dot lower. Then remove unwanted punctuations and number. Remove unwanted punctuations and numbers. So we will use regular expression. I'm going to copy it. Use the regular expression. Text will become remove it. Text regular expression dot sub pattern is going to be this from, and replace it with this from text. Then tokenize tokens, and we are doing what? Word tokens we are using to convert it into tokens. And then we are using remove stop words and lematize. Remove words and lematize. So tokens will become for words in tokens. Word. If word not in uh, yes. So yes, I'm going to copy it. Yes. So if the word is not going to be in the stop words, then we are going to include it. And first we will do lematize the word, and then after that we will do what? We will include the ones which are not in the stop words list. Once done, return the tokens. Okay. Mm, hmm. Now we apply preprocess function to each snippet of the text and store the cleaned and tokenized data. Hmm. Now whatever text we have received, for each text what we are doing, we are preprocess passing it to our preprocess function because we want to clean it. So what we are doing, clean the data. So we are doing what? We have to apply preprocessing to text data. Apply preprocessing. So how we are doing it? Clean data. First we are passing preprocess the text, and for text in text data, for each text in the text data, pass it to that. Understand? Okay, now it should be okay. Yes. Now create a dictionary and corpus of LDA. What we want to do? Create a dictionary and corpus of LDA. What we want to do? We want to create a dictionary. I guess we have done something similar in past also, where we created a dictionary. for spam, filtering, classifying an email as spam or not spam. We're doing something similar here, and we did this something similar there also. Now, if we come here, so create dictionary and corpus. A dictionary maps each unique word in the dataset to a unique integer. This is necessary for Jensen's LDA model to operate. So for Jensen's LDA model to operate, we are going to create a dictionary where each unique word of the dictionary will map to an unique integer ID. And the corpus is going to be a bag of words. We saw that in the same problem where we were understanding the, let me say, email. Yes, on day 5 we saw how to classify an email as spam or not spam. So we did something similar. We created a bag of words there as well. Representing of it converts each document into a list of tuples where each tuple represents the word's ID and its count in the document. Okay. So for example, the corpus is going to be, for example, the clean text looks is going to look like, and the dictionary is going to look like this: apple, banana, apple. If the clean text looks like this, the dictionary will map apple 0, banana 1, and the corpus is going to look like in each document. This this is appeared twice, and this banana has appeared how many times? Once. For each integer, it has appeared how many times? That is going to that is what it is going to create an array or a list actually. That is a list of tuples where each tuple represents the word unique ID and its count in the document. So let's do that. Dictionary corpora dot dictionary, and we are going to pass the clean data. Then we are going to create corpus, and uh, for for text in text for text in clean data. For now, we are going to refer clean data, not the text data. For text in the clean data, we will apply this dictionary to doc to bag of words, bag a bag of words on this text that has been received from this for loop. And we saw how how it is solving that, as in how it is generating that corpus from this example. Now we are going to build the LDA model. Now this is step number 3, step number 4, step number 5, step number 6. Build the LDA model. So what we are doing LDA model. So how we are doing that? We are doing that using Jensen dot models dot LDA model dot LDA model is here. We will pass the corpus that we have created. How many topics we want to pass? 5 topics. So the corpus, as in the corpus that we had created, bag of words represent the clean data, a representation of clean data. Number of topics is 5. We ask LD to find 5 topics. You can adjust this number to any topics we can extract. Then we have to define the parameters maps the word ID to word mapping, which is our dictionary. And this the passes count specifies how many times the algorithm should pass over the entire corpus. More passes can lead to better topic distribution but will take longer. Okay, so how many times the algorithm should pass to our corpus? So we are saying 10 times. So we will do what? ID to dictionary. Our dictionary is going to be for that mapping, ID to word mapping, and the passes are going to be 10. Now display topics. Step display topic 20. So this displays the top 10 words in each of the five topics. The LD uses a probabilistic approach to assign words to topics. See, each topic is represented by words most likely to appear in the topic. Okay. The output is going to be this, but let's see what our thing is going to print. So topics in the topics LDA model dot print topic print topics, and we say number of words. How many words we want? 10. For topic in topics print topic, let's run it. Let's run it. Okay, so it is giving us error here. Let me run it. Okay, so see, it is creating a probability for each topic. This is how it is representing. And if we want to represent it, the output indicates that the word like apple, banana, and market are prominent in the topic. Apple is this, banana, and so top five. It is difficult to explain. In this document, these are the top 10 uh, topics. In this document, these are the top 10 topic in this document. So this is how it is doing. While words like company and technology are more frequent in topic one. So we have like 10 topics, and in 10 topics we see these the number of words and their probability. Uh, Visualize topics using pi LDA visualization. Okay, step 8, visualize topics using pi LDA Python library to visualize the LDA topics. Okay, let's do what? Use pi LDA wish dot enable notebook. Pi LDA wish dot enable notebook, and I don't know what it is going to do, but let's follow what it says. LDA wish pi LDA wish Jensen prepare LDA model corpus, and then parse the dictionary. Then what do py LDA wish dot display LDA wish like. So let's do what? I'm going to comment it for now, and this as well, and run it. Okay, it says that the feature requires Python 1.2. So I'm not able to see it. So I'm going to keep it as it is. But what I've understood is it says that we can adjust the numbers here. And yeah, so yes, what we can do. So LDA, why do we use LDA? LDA we use to get the uh, we use a statistical model to get used for modeling and phrasing. So it discovers the abstract topics in a collection document. So we are able to get the topics in a collection of documents. So we got 10 topics, and we got the in each topic we got how many 10 we got words in their probably in their what, yes, according to their probability. Yes, that is how by the words most likely to appear in the topic. So that's what we are doing. We are able to get the topics out of the documents that we were given. We have used in this articles appears 2014. This problem is a little difficult for me to digest. I guess I'm not able to make sense out of it because this is the first problem of NLTK. I mean, problem of natural language toolkit. Maybe in future I'll be discussing. Maybe in future, maybe what I can do, I can prepare to solve 10 or 20 problems on this only to get more out of this topic. So yes, I would like to finish this thing here only because I'm able to do what I've been planning and starting. This is not working for our case, so I'm going to comment it. And let's commit the code and be done with today's problem. So add code for day 20. So I'm able to see that we can see the code for day 20. So yes, now I'll go and publish it on my this tech journal, this detailed description, and maybe publish the same thing, the video on my YouTube channel. Um, I'm not really happy with how I solved this problem today. But yeah, this is the first time I'm doing something related to NLT, so maybe in future I will do better on it. So yes, thank you very much.